Everyone says China builds fast, that it relies on cheap labor or copied ideas. But what you're about to see destroys that myth completely. These are not future concepts or test machines. They are colossal machines operating right now, machines so massive and advanced they look unreal. Excavators that swallow entire landscapes, robots that build skyscrapers almost by themselves, and floating factories that create land in the middle of the ocean. Stay with this video, because each machine on this list is more brutal than the last. And when you reach number 1, you'll understand how China can build entire cities in just months. Number 8. Mountain Terraformer. We begin with a machine so enormous that seeing it for the first time feels unreal. China's bucket wheel excavators are among the largest land-based machines ever built, standing nearly as tall as a 20-story building and stretching longer than a football field. Designed for continuous surface mining, these giants are capable of extracting up to 240,000 cubic meters of earth per day, an amount equivalent to filling 96 Olympic-sized swimming pools every 24 hours. Unlike conventional excavators that work in cycles, bucket wheel excavators operate non-stop, making them ideal for China's vast open-pit coal mines. At the core of the machine is a massive rotating wheel fitted with dozens of hardened steel buckets. As the wheel turns, it systematically scrapes away entire layers of soil, rock, and coal, feeding material onto conveyor belts that transport it for processing. The excavator moves slowly on multi-track crawler systems, each track distributing immense weight to prevent sinking into soft ground. Because of their enormous power demand, these machines require their own mobile electrical substations. China primarily deploys them in Inner Mongolia and Shaanxi, where coal deposits are spread across enormous areas. Once these machines pass through a site, the terrain is permanently altered, making this less like mining and more like industrial-scale reshaping of the landscape. Number 7. Earth Crusher. At number 7 is a hydraulic mining shovel so powerful it makes standard construction equipment look insignificant. These mega shovels stand over 22 meters tall and are engineered to handle the extreme demands of large-scale mining. Each scoop can lift up to 75 tons of material, roughly equivalent to the weight of 12 African elephants, allowing massive volumes of earth to be moved in a single motion. With excavation forces exceeding 3,000 tons, these machines can break through solid rock without the need for blasting, reducing both time and environmental disruption. Developed by China's state-owned heavy equipment manufacturers, these shovels operate in some of the country's largest open-pit mines, including those in the Ordos Basin. Despite their size, they are controlled by a single operator seated in a reinforced cabin equipped with climate control, 360-degree cameras, and real-time monitoring systems that track pressure, stability, and mechanical wear. In a single shift, one of these machines can move as much material as 50 conventional excavators combined, dramatically improving efficiency. Watching it work is striking. Each scoop removes huge sections of terrain, rapidly transforming solid rock into deep excavation pits. Number 6. Bridge Dragon. Now we move into territory that feels almost like science fiction. The SLJ 900/32, often called the Bridge Building Dragon, is a 580-ton, 91-meter-long machine, designed specifically to assemble large bridge spans for China's high-speed rail network. Instead of relying on cranes or temporary scaffolding, this machine positions itself directly on bridge piers and carries massive, prefabricated beams weighing up to 900 tons within its structure. Using laser guidance and computerized control systems, the SLJ 900/32 lifts, transports, and lowers each beam with millimeter-level accuracy. It then advances forward and repeats the process, effectively walking along the bridge as it builds it. This method dramatically reduces construction time, labor requirements, and safety risks. China has used this technology extensively to expand its 40,000-kilometer high-speed rail system, allowing bridges to be built in hours rather than weeks. When viewed from a distance, it appears as if the bridge is assembling itself in mid-air. Number 5. Drilling Serpent. At number 5 is a machine that rules the underground world. China's tunnel boring machines, commonly known as TBMS. These machines are enormous cylindrical systems, with some of China's largest models reaching 17 meters in diameter, wide enough to accommodate multi-lane underground highways. Designed to operate in extremely complex geological conditions, these TBMs can drill through hard rock, clay, sand, and mixed soil layers at speeds of up to 15 meters per day, even under high water pressure. What truly sets modern Chinese TBMs apart is their level of integration and automation. The rotating cutter head at the front is equipped with hundreds of hardened steel and tungsten cutters that continuously grind rock into fragments. As excavation progresses, the rear section automatically installs prefabricated concrete lining segments, bolts them into place, seals joints to prevent water leakage, and integrates ventilation ducts, drainage pipes, electrical cabling, and monitoring sensors. During projects like the Beijing Metro and large intercity rail tunnels, dozens of TBMs operated simultaneously at depths of 40 to 50 meters, passing safely beneath historic buildings, rivers, and dense urban foundations without causing surface damage. Once a TBM completes its route, it is either dismantled underground and removed in sections or sealed permanently within the tunnel, becoming an unseen but essential part of the infrastructure it helped create. Number 4. Rubber Leviathan. The fourth position belongs to a vehicle that redefines heavy transportation, the 600-ton mega hauler. These ultra-large mining trucks are designed to transport massive quantities of rock, coal, and earth across extreme terrain. With tires measuring up to 4 meters in diameter and engines producing close to 4,000 horsepower, a single hauler can carry loads equal to 10 fully loaded shipping containers in one trip. Despite their enormous size and weight, these machines rely heavily on advanced digital systems. Onboard computers continuously manage steering angles, suspension height, braking force, and traction control, allowing the truck to remain stable on uneven or sloped terrain. Many models also use GPS guidance and real-time load monitoring to optimize efficiency and prevent mechanical stress. These haulers operate primarily in China's large open-pit mines in Inner Mongolia, where moving material quickly and reliably is critical to production. When fully loaded, their movement generates measurable ground vibrations within a 100-meter radius, emphasizing the immense mass in motion. Without machines like these, large-scale modern mining would be physically and economically impossible. Number 3. Island Maker. In third place is a machine capable of altering geography itself, the Tian Kun Hao Cutter Suction Dredger. Measuring approximately 140 meters in length, this vessel is designed to excavate seabeds and create new land on an industrial scale. It can operate at depths of up to 35 meters, cutting through sand, clay, and even compacted underwater rock with remarkable efficiency. The Tian Kun Hao uses a rotating cutter head equipped with tungsten teeth to break up seabed material. Powerful pumps delivering a combined output of around 23,000 horsepower suck up the liquefied sediment and transport it through pipelines that can extend up to 15 kilometers, allowing engineers to deposit material far from the dredging site. At peak capacity, the dredger can move approximately 6,000 cubic meters of sediment per hour, enough to fill 2 Olympic-sized swimming pools every hour, non-stop. This incredible efficiency has enabled China to rapidly expand artificial islands, reclaim land from the sea, and reinforce vulnerable coastlines, particularly in the South China Sea. The Tiankun Hao is also used in creating large port infrastructure, offshore industrial zones, and even recreational islands. From an engineering perspective, it represents a rare class of machine that does not adapt to the terrain, it actively creates it, reshaping coastlines and altering maps with unmatched precision. Number 2. Building walkers. At number 2 is a technology that defies traditional construction limits: self-propelled modular transporters. These systems allow engineers to lift and relocate entire buildings intact without dismantling them. Each SPMT is composed of multiple hydraulic wheel modules, all synchronized through a central computer that precisely controls movement, weight distribution, and leveling in real time. In a famous example, a 7,600-ton school building in Shanghai was relocated tens of meters without disturbing classrooms or breaking windows. Each wheel module supports 30 to 40 tons, and hundreds of modules work together to maintain perfect balance. Advanced sensors constantly adjust hydraulic pressure to compensate for uneven terrain, ensuring minimal stress on the building structure. SPMTs aren't just for moving schools. They have been used to relocate historic temples, bridges, and industrial facilities. China plans to expand this technology for urban renewal projects, making it possible to preserve entire neighborhoods while modern infrastructure is installed around them. This technology also reduces demolition waste, preserves cultural heritage, and minimizes disruption to residents. Essentially, it turns the city itself into a dynamic, movable structure, something almost no other country can do at this scale. Number 1. Skyscraper Robot. At number 1 is the machine that best explains how China builds entire cities at record speed. Automatic climbing construction platforms. These systems turn skyscraper construction into a semi-automated production line. Anchored to the building's central core, the platform works like a vertical factory, rising with the structure and handling most of the construction process from start to finish. Robotic systems on the platform place steel reinforcement, position formwork, pour concrete, and check alignment using laser-guided sensors. Every step is monitored in real time to ensure accuracy and structural safety. Once a floor is completed, massive hydraulic jacks lift the entire platform to the next level, ready to repeat the process without cranes or traditional scaffolding. On projects like Tianjin Tower 118, this technology made it possible to complete up to 4 floors per week, with deviations of less than 2 millimeters. The system also improves safety by reducing the number of workers exposed to extreme heights and harsh weather. Built-in sensors and basic AI systems analyze each construction cycle, allowing the platform to adjust and improve efficiency over time. This is why China no longer depends on huge labor forces to build skyscrapers. With machines like this, construction becomes faster, safer, and far more precise, changing how modern cities are built.